Hi, I'm Joe Ryan, an engineer here at Precision Digital. And in this video, we're going to be walking you through the basic setup steps for a PD548 Nova process and temperature controller. For this example, we'll be programming the Nova controller, a PD548, that's used to control our engineering environmental test chamber. This setup will include an RTD input, a 4 to 20 milliamp output that'll control the heating elements, an output high alarm that'll be run off of one of the main relays, and it'll be set up for easy auto manual switching. The first step in programming any Nova process and temperature controller is programming the inputs. To get into the setup menus, I'm going to hold the blue Set Enter button for 3 seconds. This gives me, in my process value window, the display of which programming group I'm in this case the auto tuning group. And in the lower window, once I'm into a group, it's going to show me the parameter I'm programming and the setting. So as I said, the first step is to go program my inputs. To navigate through the different groups, I'll use the down arrow key. I'll eventually reach my password, which by default is set to 0, so I'll hit the Set Enter key to continue. And I'll continue down until I get to the input group. At the input group, I'll use the Set Enter key to view my setup parameter and what I'm setting it to be. So in this case, my input type. And I'm going to use the up arrow until in the set point window displays PTB. PTB can be found in the instruction manual and is a range for the RTD to let it know where to display the decimal point and what kind of accuracy is required. Once I have set up that I want an RTD input, I have additional options such as setting up the temperature units, which I want to remain degrees Celsius, setting up maximum display range high and lows, and other more complicated input features which aren't needed for this setup. I press the Set Enter key until I return to my input group. The second step is to program what my outputs are going to be configured for. To maneuver to the output group, I'm going to push the down arrow until I see my group is the output group. Again, to enter the output group, I hit the blue Set Enter key, showing me in my process variable window what the parameter is I'm setting, and in my set point window, what it's set to. Output 1 is a main relay that every Nova controller comes with. In this case, I want to leave it programmed for ALM1, which will reference alarm 1, which we'll set up at a later point. I'll confirm that by hitting the Set Enter key, showing me output 2. Output 2 is an analog output that can be configured for PID control or as a retransmitting output. In this case, heat lets it know that I'm going to be using it for PID heating control, which is what this application calls for. If I wanted to program it to be a retransmitting output, I'd push the up arrow to confirm that I want RET, but I'm going to choose to leave it to display heat. Now the heat parameter asks me what type of control I'd like. Do I want solid state relay pulsing control? Or do I want SCR 4 to 20 milliamp control? For a 4 to 20 heating output, I'm going to change it to SCR and select it by hitting the Set Enter key. With both of my outputs programmed, I now hit the Set Enter key until I've gone back to my output group. If I had additional outputs in the unit that needed programming, I'd program them the same way. Now that I've programmed that I want output 1 to be an alarm relay and output 2 to be my heating 4 to 20 milliamp output, I have to tell it what I want alarm 1 to be. To do that, I hit the down arrow key again to get to the alarm group. Hitting the Set Enter key brings me into the group where I have parameter ALT1, which asks what type of alarm 1 is going to be. By default, it's set up to be an alarm that triggers on a high value. If I wanted an alarm that triggered on an absolute low value, I'd simply hit the up arrow to select AL. There's numerous types of alarms available in Nova controllers, and your manual will reference you to what they all equate to, including deviation alarms from set point or absolute value high and lows. In this case, I want a high alarm to be triggered on an absolute value, so I'll leave it at the default AH.F. Hitting the Set Enter key moves me on to my next value, which is AL-1. AL-1 is that absolute value that my alarm will trigger on. I'm going to set that for 120 degrees. In this case, That's the temperature I'm interested in knowing if I go over based off of heat rise test that will be performed in the chamber. Once I've set the value using the up, down, and left arrows, I hit the set enter key to confirm it. The display stops flashing. And I again hit the enter key to move on to my next parameter. The deadband is the process variable we'll need to fall back by before it'll allow the alarm to be reset. To prevent relay fluctuations, I'm going to set a deadband of 2. This means that my alarm will trigger at 120 degrees and it will reset at 118. Now that I've already hit the set enter key to confirm, I'll hit it again to move on to the next parameter. This sets up the delay for alarm 1. In this case, I have no desire for a delay, but if I did, I would punch in the number of seconds that I wanted the alarm to delay by before triggering. With no alarm 2 values set or alarm 3 values set, I'll again hit the set enter key over until I get back to my alarm group. With my output set as PID and my alarm now set up, I'm going to go make it easy for me to switch between auto and manual control of my PID outputs. To do that, I'm going to go to my control group, which is the default group for non-output based parameters. Again, hitting the set enter key brings me into that menu, and I'm going to press it until I reach parameter US1, which stands for User Program Screen 1. A reference table in the back of the Nova manual lets me know that the auto manual switching parameter is at location 105. I punch in 105 with the up, down, and left keys, confirming it with the set enter key. Now that my basic programming is complete, I want to verify that US1 is actually 105 and does reference the parameter I wanted. To leave the programming menu, I hold the set enter key for 3 seconds, just like I did to enter it. Now with US1 set, I can press the blue set enter key to see what the percent is of my PID outputs, and I can hit it again, referencing parameter 105, my auto manual switching parameter. To switch from auto control of my PID outputs, I use the up key to switch it to manual, press enter, and now it automatically brings me to the output percentage screen, allowing me to ramp that up and down with the up and down arrow keys. To return it to automatic control, I press my enter key, which again quickly brings me back to my auto manual parameter, turn it back to auto, and press the enter key again. A final time returns me to my process variable and set point windows. The last setup requirement, now that my outputs are programmed to be alarms and PID outputs, and that my input's been programmed to be an RTD, is to auto-tune the system for this particular setup. Auto-tuning PID controllers mean you don't need to know what your proportional, integral, or derivative values are. It'll run the process up and down, acquiring what those PID values are for you, and then eventually return to normal operation based on the set point. In order to begin auto-tuning, first I'm going to use the arrow keys to program my set point to something that approximates what an actual example of this setup would be. In this case, I'm going to set it to 85 degrees, which is a common temperature that we run our tests at. Just like a parameter, I change my set point with the arrow keys and confirm that change with the enter key. To begin the auto-tuning process, I'll enter my setup menus by holding the set enter key, select the auto-tuning group, press the enter key to enter it, and at the AT, the auto-tuning parameter, I'll change it to on, and I'll press enter. It immediately returns me to my process variable and set point window. The output light turns solid as it begins putting 100% output, and the manual light will continue to blink so long as I'm in the auto-tuning process. Once the manual light turns off, I know it's safe to begin normal process operations. For more information or demonstrations on how to set up your Nova controller, please visit www.predig.com. On our homepage is a link to our Nova virtual meter demo. This demo is an interactive demonstration that includes on the left-hand side information on how to set up common applications for Nova controllers. Simply click on what you're interested in and will give you instructions on how to set up your controller. The controller, as seen here, is fully interactive, including the ability to hold the Set Enter button, to enter your setup groups, to cycle through them, and see what the screens will be as you follow through with your application setup.